So for the very last part of the proof, we also have to consider non-zero limit ordinals. But those go exactly the same way that successor ordinals did for the most part. I mean, of course, they seem quite a lot different because there is no beta to which we could refer. But in fact, we would then know that for every ordinal less than it, the theorem holds. And since the limit ordinal is just defined as the union over all of those such things, the proof is really going to go pretty much the same way. So, okay, I'll regard that was a very fast and kind of sort of weaseling my way out of having to give a full expression of the proof. But I think the proof, with that kind of a proof sketch, the actual details of the proof are fairly simple, so I skip them. Now, right on the heels of this, we have a corollary, which is, well, I'll let you read it here, but it essentially just says that that for the set of all sequences of length less than theta, that we can basically index them, right? That we can come up with a recursive construction of a sequence in them. So it follows from the previous theorem that if we fix any alpha, which is basically doing what we have to do for a for all sentence. So fix some alpha, we will find the unique sequence, and in fact, the sequence is exactly that which satisfies the existential claim in the statement of the theorem up here, right? Beginning with orange existential. So the sequence that satisfies that is going to be the sequence that we use for the corollary. Okay. Finally, we have these definitions of limits and normal and continuous. So the limit of a non-decreasing sequence, which is defined exactly how you would think that it would be defined, is defined as the soup over all the sequence terms. And a sequence is called normal if it is, or non-decreasing, I think is the right thing to have here, not increasing, but non-decreasing, and continuous, where continuous means that just if you take any limit, it's equal to, any limit at alpha, it's equal to the sequence term at alpha. And so in the next video, we'll start discussing ordinal arithmetic.